Last time we looked at stoichiometry, at least middle step of stoichiometry, where we were using the balanced chemical equation to convert from moles of one thing or relate moles of one thing to moles of the other thing. So I kept talking about scaling up the recipe. And this was actually the question that was the last thing that we saw. So we had a reaction where we had, in the thing that we were interested in was 19 moles of oxygen that would be part of a reaction to produce 14 moles of water. And the question was, well, how many moles of oxygen would I need to produce 5.6? So different from the balanced chemical reaction, but still following that pattern. And the numerical answer was I start with a ratio where half of the ratio comes from the balanced chemical reaction, the recipe of the reaction. So 19 moles of oxygen, 14 moles of water. And then the other half of the ratio is the version of it that I'm trying to use. How much would I need for 5.6 moles? And if I do that math, I end up with 7.6 moles of oxygen. All right, so just following the recipe or the pattern, but then scaling it for different amounts. Now the thing with stoichiometry, the reason that we need to do stoichiometry and the reason why we need a bigger thing for stoichiometry is that we actually work with masses, not moles. So the whole thing with stoichiometry is I need to work with masses, but the reaction uses moles or particles, but we count those particles in terms of moles, and then I need to finish up with masses. So stoichiometry is going to be 3 steps, but a couple of those steps are just converting from my units to chemical units, and then from chemical units back to units that are comfortable for me. So we're going to take my favorite reaction again, and the question is how many grams or what mass of hydrogen would react with 100 grams of nitrogen. So if I had that reaction, that is now a kind of a typical or a reasonable kind of question to ask. Or I could ask what mass of NH3, my product, would be produced if I started with 15 grams of hydrogen. And again, hopefully you can imagine that that's a pretty reasonable kind of question to ask. I work with masses. The problem is the reaction doesn't. It uses moles. So we're actually going to work through a slightly different question, but again, either of those other two would have been okay. So the kind of question you're going to see, the wording of the question you're going to see is going to look something like that. What mass of H2 hydrogen is required to react with 81.6 grams of nitrogen? Now we're going to break it down into 3 pieces. And the first piece is to convert from that unit that I can work with, mass, into moles. So step 1 is going to be convert from mass of known that I was given in the question to moles of known. So I'll just convert that to moles. So in other words, the first piece of the question is how many moles of nitrogen are in that 81.6 grams? Well, we know how to do that. We do that by using the molar mass. And we take the mass that we're given and we divide it by the molar mass. So in this case, 81.6 grams divided by 28 grams per mole for nitrogen. Nitrogen is 14 each, 2 of them, 28 grams. And when I do that math, I get 2.9 moles of nitrogen. Now that's not the answer to the final question, but it's the answer to the question of how many moles of nitrogen in 81.6 grams. So now that I know how many moles I'm dealing with here, I'm going to convert that into moles of the other. I'm going to follow the recipe. So my new question becomes how many moles of hydrogen would react with 2.9 moles of nitrogen, which again, that's a question we were doing last time. So I'm going to use that balanced chemical reaction and I'm going to set up a ratio. So 2.9 moles of nitrogen into that ratio where, again, half of the ratio, in this case the left side of the ratio, are the numbers that come from the balanced chemical equation, the recipe, and then the other side is working with the parts that I have, the 2.9 moles, and scaling it for those new amounts. And when I do that, I get 8.74 moles of hydrogen. So if I want to use 2.9 moles of nitrogen, I'm going to need 8.74 moles of hydrogen. Okay, so the third step, I should pause there and point out that I could have asked the question of how many moles of hydrogen would react with 81.6 grams, because at the end of my step 2, that's what I know. My last step is to turn those chemical units, those moles, back into grams so that I know what it means. So I left off with 8.74 moles of hydrogen. My question was, how heavy is that? How much mass is that? So I need to know that. Well, I know how to find mass. I use number of moles times the molar mass. Now in this case, it's going to be the number of moles of hydrogen, which I just figured out, times the molar mass of hydrogen, which I'm going to have to figure out, but it's 2. So mass times molar mass, number of moles times molar mass, is 8.71 moles times 2 grams per mole, and that's going to give me 17.48 grams of hydrogen. Pretty easy. Now at the end of it, I started out with 81.6 grams of nitrogen, and I turned that into moles of nitrogen, then I turned that into moles of hydrogen. Now I turned that back into mass of hydrogen. So now I have the answer to the question, what mass of hydrogen would I need to react with 81.6 grams of nitrogen? I would need that much, 17.48 grams. And that's it, that's stoichiometry. Okay? So if the question started out like that, that's the steps I would go through, all 3 of those steps. Now I have to go through those 3 steps every single time. These are the 3 steps, and these are the things that you have to do. Step 1 is always mass divided by molar mass. The molar mass will change depending on what it is I'm talking about. Step 2 is always going to be involving the ratio. Half comes from the balanced chemical reaction, half comes from the thing I don't know and the thing I do know. And then the last step is always going to be mass is number of moles times molar mass, where again the molar mass is going to be different depending on the formula, depending on the compound that I'm looking for. Okay, so we're going to try one. Where I've got a reaction where I've got C3H8 reacting with oxygen to form carbon dioxide and water. And the question is, what mass of carbon dioxide would be produced if I also got 53.6 grams of water? So I'm going to go through those 3 steps again. Mass of known to moles of known to moles of unknown, finally moles of unknown to mass of unknown. And I'm going to start with my mass over molar mass question, and then I'm going to go to the ratio, and where I use the number of moles that I calculated in step 1, that becomes the bottom part of the reaction in bottom part of the ratio, not reaction, in step number 2. And then once I know X on that top part of the ratio, I'm going to use that to find, to multiply against the molar mass to find the total mass. So if we go through that step by step, first step is mass divided by molar mass. Mass given was 53.6 grams. Molar mass of water, figure it out if you don't trust me, but work it out on your own, but 18 grams per mole. That gives me 2.98 moles of water. Okay, great. If I have 2.98 moles of water, how many moles of carbon dioxide would I have? Oh, that's a ratio. That's a ratio where 3 moles of carbon dioxide form when 4 moles of of water also form. So following that recipe, what would it mean for 2.98? Solving the ratio, I would get 2.24. And please push the buttons on the calculator. Make sure you've solved it for yourself. Don't take my word for it. Next step is to turn that number of moles of carbon dioxide into a mass. So the last step was 2.24 moles of carbon dioxide. How much does that weigh? Well, I'm going to take my number of moles, 2.24, and I'm going to multiply it by the molar mass of carbon dioxide. So 2.24 moles times molar mass of carbon dioxide, which is 44 grams per mole. Again, don't take my word for it. Try it out yourself. To give me 98.56 grams of carbon dioxide. And if I go all the way back to the question, I thought I had it there. Again, if I go all the way back to the question, which said what mass of carbon dioxide would be produced if, this is the answer. I would produce 98.56 grams of carbon dioxide. I'm going to get you to try one. What we'll do is I will show you the question, I'll give you the answer. Actually, I think I have the answers to each one of the steps, but please do those steps on your own to make sure that you can make sense of it. But that's the question. You may need to pause the video to work it out, unless you're really fast at stoichiometry. But after doing the first step, figuring out the numbers of moles of water, H2O, it should give you the number there from 3.54. Then after doing the ratio step, you should end up with 4.8 moles of oxygen, and then turning that into a mass, it should give you 153.7 grams. Please do the full stoichiometry on your own, but those are the target answers. If you don't get one of those, go back and look. Two most likely places. Number one is coming up with the wrong molar mass. Second most likely is something's wrong with the ratio. In fact, often it's the ratio that's the problem. Okay, this one I want you to try on your own. I don't have the final answer here for you. Unless I have the very final answer, I forget what I've done. But pause the video if you need to, or do it at the end. But this one. In big picture, the 3 steps are always going to be measurable of known. So for our case, that's the mass, how much it weighs. The mass of known, you're given it in question, to turn that into numbers of moles. Then you're going to turn numbers of moles that you know from the previous one into the moles of the thing that you're looking for. And then finally, you're going to turn it from the moles that you just found out, the thing that you're looking for, turn that into some kind of measurable thing. For us, it's always going to be mass. But you could do stoichiometry, you're talking about solutions or gases or anything else. At this point, you should be able to do full mass stoichiometry. It's going to take some practice before we're comfortable at it, but based on the things that we've done, that's all there is to stoichiometry, as long as you do all 3 steps every single time. Stoichiometry is not difficult, but it does get a little bit tedious, and it takes a bit of getting used to. But other than that, it's just practice. Talk to you another time.